Hello students. In this lecture we are going to learn about the Slater's rule. What is Slater rule and how we calculate the effective nuclear charge and shielding constant with the help of Slater rule. Slater rule is a rule which proposed certain rules to calculate the screening constant for electrons in different shells. With the help of screening constant, we easily calculate the effective nuclear charge because we know the formula of effective nuclear charge, that is Z minus S. So first we have to calculate the shielding constant according to Slater rule. First step to find the shielding constant is write the electronic configuration for the atom in the following order. Like I have to write the orbitals in some groups. Orbitals of first shell 1s in one group, 2s 2p in one group, 3s 3p in one group, and will keep 3d separately and so on. In this grouping, the s and p orbitals of a shell are written together while d and f orbitals are written separately. Second step is identify the electrons of interest and ignore all the electrons in higher groups. What does that mean? When the question is like to calculate the shielding constant in 4p electrons. So we consider the electrons up to 4p orbital and the rest of it we ignore, like 4d, 4f, 5s, 5p. We ignore all the electrons. We consider only up to 4p orbitals. Third step is for s and p orbital electrons. When we calculate the shielding constant, the rules are different, and for d and f orbital electrons, rules are different. So first we will talk about the for s and p orbital electrons, what are the rules. So these rules we will discuss with the help of, we understand with the example. So the question is, what is the shielding constant experienced by a 2p electron in the nitrogen atom? In question, we have to find the shielding constant of 2p electron. So first we write the electronic configuration of nitrogen. We know that the atomic number of nitrogen is 7. So electronic configuration of nitrogen is 1s2, 2s2, 2p3. So now we apply the Slater rules. First step according to Slater rule is arrange the electronic configuration in groups. So 1s2 in one group, 2s2, 2p3 in one group. Second step, we have to find the how many electrons present in same group. Like 2s and 2p, there are 5 electrons in one group. But we have to find the screening constant of one electron that is present in 2p orbital. So remaining there are 4 electrons. So according to step 3, according to Slater's rule, for s and p orbital electrons, first step is electron within same group shield 0.35. So 4 electrons shield 0.35 each. So we multiply 4 into 0.35, that is equal to 1.4, and the remaining n-1 group shield 0.85. So n-1 group is 1s orbital. So there are 2 electrons which shield 0.85 each. So we multiply 2 into 0.85, that is equal to 1.7. Now we add 1.4 and 1.7, that is shielding constant. So shielding constant is equal to अपने को 1.4 plus 1.7 is equal to 3.1. Now we calculate the effective nuclear charge. So we know the formula of effective nuclear charge, that is equal to Z minus S. Z is the atomic number, S is the screening constant. So atomic number of nitrogen is 7. 7 minus shielding constant 3.1 is equal to 3.9. So shielding constant of 2p electron in nitrogen atom is 3.1 and effective nuclear charge of nitrogen atom is 3.9. For d and f orbital electrons, how we calculate the shielding constant? This can be also explained with the help of example. So the question is, what is the shielding constant experienced by a 3d electron in the bromine atom? First we write the electronic configuration of bromine atom, that is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. According to Slater rule, we arrange the electronic configuration in groups. So 1s2 in one group, 2s2p in one group, like that we arrange the electronic configuration. Step second. For d and f orbital electrons, first is electron within the same group shield 0.35. So we have to find the screening constant of one electron present in 3d orbital. So there are 10 electrons in 3d orbital. Remaining electrons are 9. So 9 multiply 0.35, that is equal to 3.15, and electrons within the lower group shield 1.0 each. So there are 18 electrons which shield 1.0 each. So 18 into 1 is equal to 18. So shielding constant, when we add both terms, 3.15 plus 18 is equal to 21.1. And effective nuclear charge is equal to Z minus S. Atomic number of bromine atom is 35. So 35 minus 21.1 is equal to 13.85. So this is all about the Slater rule, and with the help of Slater rule we can easily calculate the shielding constant. Then we find the effective nuclear charge. Thank you.